So hello everyone, welcome back to the YouTube channel, and today I'll be posting the solutions of first three questions of the weekly contest 330. So let's move to the first problem, that is count distinct numbers on the board. So I will suggest to read the problem statement by yourself and try to solve for every problem, and then if you are stuck then you can continue watching. I think that most of you have tried this contest. So yeah, so in this problem you are given a positive integer n that is initially placed on a board. Then for every 10 to the power 9 days you perform a procedure. Like the procedure is, for every number that is present on the board you find all such numbers whose division will give a remainder of 1. Like if you pick a number x which is present on the board, then all the numbers from 1 to n, you will divide all the numbers 1 to n. You will divide x by all the numbers from 1 to n, and the numbers which will give a remainder 1, then you will place those numbers on the board and you will continue. So for example, you start with n equal to 5. So initially 5 is present on the board. Now you check for 1 to 5. There are two numbers like 2 and 4, which when divided by 5 gives remainder 1. So you place 2 and 4 on the board. Now there is no number for 2. Now you add 2 and 4 to the board. So for now 2, there is no number like whose remainder would give you 1. So you check for 4. Now for 4 you find that there is number like 3, which on divided by 4 will give you a remainder 1. So you will add this number also to the board, and so on. So at the end you have to return the total number of distinct integers. Basically all the numbers except 1 can be added. So like for 5 you can add 2, 3, 4 and 5, and like for 3 you can add 2 and 3. But one number will never be added, 1, because any number divided by 1 gives remainder 0. So only one number will be not present, that is 1, and all the numbers can be added to the board. So you have to basically return n minus 1, except for the case when n is equal to 1, because when n is equal to 1 there is only one number present, that is 1 itself. So this is the code. You can see like if n equal to 1 you return 1, else you return n minus 1. So let's submit this. Yeah, accepted. So let's move to the second question now. Yeah, so you can read this problem again as I said. So now in this problem you are given n vertices, regular polygon, and the vertices are numbered from 0 to n minus 1, and at each vertex there is a monkey which can jump either to the right neighbor or to the left neighbor. So you have to return the number of ways so that the monkey can move, so that at least one collision happens. Like the ways in which the number of collisions is 1 or more. Collision is defined here as if at least two monkeys reside on the same vertex after the movement. This one. So means you have to consider all the moves where collision happens greater than or equal to 1, which can also be said like the total collisions except those collisions where the total ways to make jumps except the ways where no collision happens. That will be the required result, that is at least one collision happens. So total ways will be like at each vertex monkey have two choice, either to the left or to the right. So for n vertices there will be 2 to the power n choices. So the total number of ways that monkey can move are 2 raised to the power n. And okay, so now we have to find the ways such that no collision happens, which can be like if all the monkeys move in the same direction by one step, like 0 move to 1, 1 move to 2, 2 move to 3. Or there is another possible way like 1 move to 0, 2 move to 1, 3 move to 2. Like all the monkeys jump to the neighborhood but in the same direction and in the same direction, like once clockwise and once anti-clockwise. So there are only two ways in which no collision will happen. So yeah, now let's see the code. So this is our function which we have to implement. So yeah, see, I have written here like total ways minus ways such that no collision occur. So for total ways you have to find 2 to the power 2 raised to the power n, and since it can be large, so you have to find it modulo 10 raised to the power 9 plus 7. So this is a function, modular exponentiation basically. uh, you can read more about it. We are basically finding here x raised to the power y mod p, like x raised to the power y whole mod p, because this can result in overflow. So this is the function, this function is doing x raised to the power y mod p. So we find the total ways from this function passing to n and m, where n is given, and 2 raised to the power n mod m minus 2, that are the ways that no collision occurs. Yeah, so let's submit this one also. Yeah, accepted. So now let's move to the third problem. Put marbles in bag. Yeah, so you can first of all try this problem by yourself. Now in this problem we have given k bags and some marbles, and the weights of those marbles are given in the form of array weights I, where weights of I represent the weight of the ith marble. And you're given k bags, so you have to divide the marbles into k bags such that 3 conditions are fulfilled, like no bag is empty, and if the ith and jth marble are in the bag, then all the marbles between those index should be in the same bag. If a bag contains all, so basically it is saying that you have to divide this array into k sub arrays. What the question is trying to say, what is the meaning, like I'm telling you that, like you have to divide this array into k sub arrays, k non-empty sub arrays, because no bag can be empty. Like you can divide like 1 3 and 5 1, so such that, so here's case 2, so we have divided into 2 non-empty subarrays, and the cost of the division will be sum of the starting and last index. Like if you divide it, so consider this distribution, like one subarray is only 1 and second subarray is 3 5 1. So the result, so the cost is 1 plus 1 2, and 3 plus 1 4, 4 plus 2 6. Like you have to take the starting index of the subarray and the last index of the subarray. Consider the cost of this, like 1 plus 3 4 and 5 plus 1 6, so it is 10. So now the score I have defined, like what is the score of distribution. Okay, so now you have to return the difference between maximum and minimum scores among marble distributions. Okay, so now let's I will try to explain you this. Consider, now you can consider this example. We are given an array like weights 2 10 5 4 3 1 6 9 and k equal to 3. Like you have to divide this array into 3 non-empty subarrays. Now you have to take the difference of the minimum and maximum. So you have to make two distributions, like the minimum and maximum scores. So for minimum you want to, so first of all you should understand that we have to divide into 3 subarrays. So like if you divide anything, like for example I divided this into like 3 subarrays starting from 2 to 4, then 3 to 6, and then 9 to 3. So you can see there is a like transition kind of thing, that where one subarray is ending and other is starting. So for, like you can see, for when we have to divide into 3 subarrays, we are having like these type of transition. We are having 2, that is for k we are having k minus 1. Okay, so now if you observe carefully, like you have to take the minimum score, right? So what you will be trying, because this sum will be, in this case, like sum would be 2 plus 4 6 plus the score for this subarray. Okay, this is 6, then 3 6 plus 3 9, and then 9 plus 3 it will be 12. So the score will be like 27. Yeah, 27 will be the score over here overall. So like you took the sum of these two elements, right, 4 and 3, although you took it like 2 plus 4, then 3 plus 6, and then 9 plus 3, but basically these two are included in the sum, then 6 and 9 are included in the sum, and the first and last will be obviously included in the sum. Okay, so now you have to like minimize. In the case of minimize, you want to make the overall sum minimum. So you will you have it is fixed that the first and last element are fixed, so you want to minimize the sum in a way that like the score is minimum. Okay, so how can you do that? You want that these transition elements should contribute minimum to the sum, because let's consider this subarray 10 is also appearing here, but for the sum we are considering only 4, so we have to overall minimize, like we so you want that sum of these two should be minimum. You can't only consider one element. Okay, like if you thought like I want to minimize, so why should I not do like this, like I go from 2 straight away from 1, and then maybe something like this, but this is not optimal because you are ensuring only one. What if the next element, which will be obviously included in the sum, is very big, like it is something like 36, but what you have done is you only considered this one in the sum, and the next is a number will obviously be included in the sum, and you didn't consider that. So you minimize the sum from the first subarray part, but this is but the contribution of the second subarray will be very much bigger, so you have to like consider the both the elements, both the like transition like thing, like you can understand something like this: one subarray, then two subarray, then three subarray. Like if you understand concept for any one of the minimize or maximize, then both are obviously same, so you have to consider something in between that both the sum of the combined should be like minimum, the starting and the ending of one. Like you have to consider these two, this should be minimized or maximized. Okay, so this only what we are doing, like here now k equal to 3. So for now let's see for minimum we have two transitions, so we will look for the minimum 2 where the sum is coming minimum. Okay, so obviously you can see one is this 3 plus 1 4. Okay, now next minimum sum which I'm seeing is 7. Okay, so now one will be this. Okay, so like how will be the subarray be divided? So it will be like it will go up to this, and the next will start from this to, and the third subarray is this itself, only single one. So you consider the sum 2 plus 3 5, 5 plus this contribution is 5, 1 plus 1 2, and 6 plus 3 9. Wait a second. Okay, so like 9 plus 2 11, and then 5 16, so the minimum sum we can get is like 16. And same for the maximum thing, this was for the minimum. So now for maximum you would have two transitions, so you want maximum in those. Okay, so one is obviously this 15 you can see here, and then one more 15 over here. So you can make subarray like from 1 to 10, then like 5 to 6, and then 9 to 3. So here sum will be like 2 plus 10, here 12, then 5 plus 6 11, and this part 9 plus 3 12. That is 35. Okay, yeah, so now we have to return the difference of these. So we have to basically store the or get the k minus 1 minimum and k minus 1 maximum. For the maximum score we have to get the k minus 1 maximum, like two adjacent maximum sums. Here we got 15 and 15, and for the minimum we have to get the k minus 1 minimum adjacent pairs. So now I'll show you the code, you will understand it better. So first, if k equal to 1, like we have to divide it into only one sub-array, that means no division will there. So minimum and maximum score will be equal. Like if this is the array, we have to keep it on only one sub-array, right? So there will be no division, and the minimum and maximum cost will be 2 plus 3. Both the cost will be 5, so the difference will be 0. Okay, so it is the base case. Then we declare a priority queue. One is a max heap and then minimum heap. By default in CPP, it is a max heap and then min heap. We can declare it like this. Okay, so now we are traversing from 0 to n minus 1, and we are calculating the adjacent pair sum in some variable, and we check if there are currently less than k minus 1, because for k we have k minus 1 transitions. So we check if there are currently less than k minus 1 element in the priority queue. So we push and update the sum. This is equal to k minus 1. We compare the top element. If the top element is less than sum, so we like pop the top element and we update the sum accordingly. That we decrease the sum by the top element and increment the sum by the current sum. So we did it for the max, and same thing we can do with min. We are maintaining a maximum heap. Like maximum heap top will be having maximum element, right? And we check if the maximum element, first of all, if the heaps there are less than k minus 1 elements, we will simply push and we will update the minimum sum. And else if there are k minus 1 elements, then we compare the top, which will be the min score is like a maximum heap, so the top element will be maximum element if it is greater than sum, but we have to maintain minimum k pairs, right? So we decrease it by the top element and pop it, and then push the new sum element and increment it by sum. Then we return max minus minimum. Okay, so let's submit it. Yeah, so it got accepted. Yeah, that was all for this video. Hope you liked it, and please consider subscribing, liking the video. Thanks.